In this video, we are going to look into trigonometric ratios of negative theta, 90 degrees plus or minus theta, 180 degrees plus or minus theta, 270 degrees plus or minus theta, and 360 degrees plus or minus theta. What this exactly means is we've seen the trigonometric ratios of just theta. We know that, sine theta equals 1 by cosecant theta, or sine theta equals just opposite by hypotenuse, and so on. In this video, let us look into the trigonometric ratios of various other angles that we may come across to, help us find the trigonometric ratio of any magnitude. So that's exactly what we're going to equip ourselves with by looking into this video, by completing this video. What we'll know when we complete this video is we'll know the trigonometric ratios of all these, but in the next video, you'll be able to solve the trigonometric ratios of angles of any magnitude. We'll see that in a bit. All right, now to start off with, we'll have to do sine of negative theta, cos of negative theta, and so on. So let's start off with negative theta for negative theta. So that's what it's going to be. So sine of minus theta, what is it going to be? It's going to be minus sine theta. Right? The negative of an angle comes into play when it rotates in the clockwise direction. When it is in the anti-clockwise direction, it's going to be positive for you. Basically, one direction, if it is negative, the other direction is going to be positive. That's the whole concept. And then we've got cos of minus theta, which is nothing but cos theta. Right? And then we have tan of minus theta, which is nothing but minus tan theta. And then we have cosecant. Cosecant of minus theta is going to be minus cosecant theta. One clue for you here is the reciprocals are going to be the same as their originals. That is, cosecant is going to be the same. The sine is going to be same as a cosecant. The sine is going to be same as a sine. Tangent, it's going to be same for the cot. Cos is going to be same for the secant. So we have cosecant. Now we have secant of minus theta, which is positive secant theta. The reason being for cos also, it's positive. Secant is just the reciprocal of cos. Then we have the cot of minus theta, which is nothing but minus cot theta. Right, so we are done with minus theta. Let us next go to, we've got 90 plus or minus theta. So let's start off with 90 minus theta. So 90 degrees minus theta. So let's start off with sine again as usual. Sine of 90 degrees minus theta. What's it going to be? Sine of 90 degrees minus theta is going to be cos theta. And cos of 90 degrees minus theta is going to be sine theta. And tan of 90 degrees minus theta is going to be cot theta. And cosecant of 90 degrees minus theta is going to be secant theta. And secant of 90 degrees minus theta is going to be cosecant theta. And cot of 90 degrees minus theta is going to be tan theta. So next we will go to 90 degrees plus theta. But before we go to that, let's quickly come back to this one here, 90 degrees minus theta. If you can observe carefully, whenever there is, the split into theta, 90, 180, 270, and 360. Well, minus theta is one case, but if you leave the theta part and if you consider these four, there are four exactly, 90. You can group 90 and 270 in one, and then you can group 180 and a 360 in one. For what reason are you grouping them? The reason being that whenever there is a 90 degrees, every trigonometric ratio becomes its opposite, not the reciprocal, but you can easily make that pairs, right? Sine and cos, tan and cot, cosecant and secant. So sine of 90 degrees minus theta is going to become cos theta, cos is going to become sine, tan is going to become cot, cosecant is going to become secant, secant is going to become cosecant, and cot is going to become tan. But in the negative theta thing, there is no sign change here at all. 90 minus theta. Now we will observe what happens to 90 plus theta. So sine of 90 degrees plus theta is going to be cos theta. And then cos of 90 degrees plus theta is going to be minus sine theta, and tan of 90 degrees plus theta is going to be minus cot theta, and cosecant of 90 degrees plus theta is going to be positive secant theta, and secant 90 degrees plus theta is going to be negative cosecant theta, and cot 90 degrees plus theta is going to be negative tan theta. Well, I am not sure what you've really observed here, but let me tell you one important point as far as this 90 plus theta is concerned. Now, if you see 90, as I told you, 90 and 270, sine is going to change to cos, sine is changed to cos, cos to sine, tan to cot, cosecant to secant, secant to cosecant, and cot to tan. But what's the difference between 90 minus theta and 90 plus theta? 90 minus theta, you're going to have everything positive, no sign change at all, because 90 minus theta is nothing but the first quadrant, right? First quadrant, everything is positive. All are positive. That's what is the first quadrant. That's why there is no sign change. Now, 90 plus theta is second quadrant. In second quadrant, only the sine and its inverse are positive, right? Only the sine and its inverse are positive. Therefore, sine of 90 plus theta is going to be positive, but it's going to become cos. And cosecant of 90 degree plus theta is going to remain positive, but it's going to become sec. But others, if you see cos, tan, secant, and cot, everything is going to become the opposite of it. At the same time, it's going to become negative as well, because the second quadrant belongs to sine and cosecant and nothing else. But what happens to it? It is the same thing whatever the 90 degree does. Cos becomes sine, tan becomes cot, secant becomes cosecant, cot becomes tan. The only difference being the signs here. Except sine and cosecant, everything is negative. So that's the difference between 90 minus theta and 90 plus theta. All right. So next we will go to 180 degrees minus theta. Alright, since we are not going to have enough space here to compare the two, let's go to a new page to do 180 degrees minus theta. So now coming to 180 degrees minus theta, we have sine of 180 degrees minus theta. Now since it's 180 degrees, sine is not going to change to anything, it's going to remain sine. Only 90 and 270 is going to make sine become cos, cos become sine, and so on. 180 and a 360 is going to make sine become just sine. It's not going to change it. And one more thing, 180 degrees minus theta is nothing but the second quadrant, the same as the 90 degrees plus theta, right? So, this is going to be 180 degrees, is going to be a 90, this is going to be a 0, this is going to be a 270, this is also going to be 360 degrees. So this is 90 plus theta or 180 minus theta. That's what it means. This quadrant, the second quadrant, can be 90 plus theta, 91, 92, 93, and so on. But the second quadrant can also be 180 degrees minus theta. 180, 179, 178, so on till 90. So that's what it is. So here, as you know, sine and cosecant are positive. And another thing, 180 degrees is going to keep sine as sine, and since it's a positive, it's just going to be sine theta. And let's go to now cos of 180 degrees minus theta. 180 is going to keep cos as cos itself, and in fact cos theta itself, but the sign is going to change. It's going to become minus cos theta because the second quadrant belongs to sine and cosecant and not cos. It's going to be positive only for sine and cosecant. And then we go to tan of 180 degrees minus theta. Now 180 is going to keep tan as tan itself, tan theta. The sign is also going to be just negative because the second quadrant, only the sine and cosecant are positive. And then we go to cosecant of 180 degrees minus theta. Cosecant is going to remain cosecant, and it's going to be positive as well because cosecant and sine belong to the second quadrant, and 180 degree minus theta is nothing but second quadrant. Then we go to secant theta. Secant of 180 degrees minus theta. 180 is going to keep secant as secant, but since secant is not positive in the second quadrant, it's going to be negative of secant theta. And finally, we're going to go to cot of 180 degrees minus theta. Cot is going to remain cot, but it's going to have a negative sign, so it's negative cot theta because negative cot theta is positive only in the third quadrant, not in the second quadrant. So that is this. So that's the end of 180 degrees minus theta. Let me quickly tell you that this is nothing but this is also the second quadrant, just as the 90 degrees plus theta. Now let us go to 180 degrees plus theta. So let's see what's the difference. One similar thing is that sine is going to remain sine, cos is going to remain cos. But what's the thing that's going to change? Only the sign. So now 180 degrees plus theta, remember, 180 degrees plus theta is nothing but the third quadrant. It's going to move from here up till 270. So let us mention that here, third quadrant. So sine of 180 degrees plus theta is going to be equal to, no doubt sine, 180 is going to keep sine as sine, but does sine belong to the third quadrant? Is it positive in the third quadrant? No, it isn't. It is only positive in the second quadrant. So therefore, it's going to be negative sine theta. And what about the cos? Cos of 180 degrees plus theta is going to be, now cos is positive in the fourth quadrant, ASTC. ASTC. All are positive, sine and cosecant are positive, tan and cot are positive, cos and secant are positive. So therefore, this is also going to be negative cos theta. The 180 keeps the cos as cos, but the third quadrant makes it negative. And then we go to tan. Tan of 180 degrees plus theta. Since tan is positive in the third quadrant and 180 degrees plus theta is third quadrant, it's going to be positive tan theta. And cosecant of 180 degrees plus theta, well, it's going to be minus cosecant theta, because cosecant theta is not positive in the third quadrant, and the 180 is going to keep cosecant as cosecant itself. And then secant of 180 degrees plus theta, it's going to be negative secant theta, because you know now. I'm sure you know by now. All right, I'm going to tell you quickly. Secant is not positive in the third quadrant and plus, so therefore it's negative, and 180 degree doesn't change sine to cos and cos to sine and so on. It just keeps the ratio as it is. And then we've got cot of 180 degrees plus theta, which is going to be plus cot theta, because cot theta is a positive in the third quadrant, and therefore it's positive cot theta, because 180 degrees is not going to change cot to tan nor tan to cot. Right, so this ends the 180s. Now I think it'll be better if we take a new page to do the 270. So it's going to be 270 degrees minus theta, or to tell you the quadrants quickly, it is going to be the third quadrant, because this is 180 degrees and this is a 270 degrees. So 270 degree minus theta is 270, 269 up till 180, right? So again, we are dealing with a third quadrant. So now let's start off with sine of 270 degrees minus theta. 270 is going to change sine to cos, no doubt about it. So it's going to become cos theta. But what's the sine going to be? It's going to be negative, because sine is positive only in the first and the second quadrants. Next, let's go to cos. Cos 270 degrees minus theta. Cos is going to change to sine theta, and it's going to be negative as well, because cos is only positive in the fourth and the first quadrants. Then we go to tan 270 degrees minus theta. It's going to be positive cot theta, because tan is indeed positive in the third quadrant. And we have cosecant of 270 degrees minus theta. Cosecant is going to change to secant theta, and the sign is going to be negative, because cosecant belongs, it's positive only in the second quadrant. And then secant of 270 degrees minus theta is going to be minus cosecant theta. Cot of 270 degrees minus theta is going to be positive tan theta, because 270 changes cot to tan, and since it's the third quadrant, tan and cot are positive in that third quadrant. So that ends the 270 degrees minus theta. Let's quickly go to 270 degrees plus theta. 270 degrees plus theta, I'm sure you know it is the fourth quadrant, because it is that side, 270 degrees plus theta up to 360 degrees. So this is the fourth quadrant, and this is the third quadrant. So let me mention here that it is the fourth quadrant. All right, so sine of 270 degrees plus theta is going to be, again, 270 is going to change sine to cos. All right, but since sine is only positive in the first and second quadrant, not in the fourth quadrant, this is going to be negative. and cos of 270 degrees plus theta. Since cos is positive in the fourth quadrant, it's going to be positive. Cos is going to change to sine theta. And we have tan of 270 degrees plus theta. Since tan is positive only in the third quadrant, it's going to be negative cot theta. 270 changes it. And then cosecant of 270 degrees plus theta is going to be negative of secant theta. And secant of 270 degrees plus theta is going to be positive cosecant theta. Because secant theta is positive in the fourth quadrant and 270 changes secant to cosecant. And then we've got the cot 270 degrees plus theta. Cot is a negative in the fourth quadrant, therefore it's going to be minus tan theta. Cot is going to change to tan. So this ends the 270 series, and we've just got one left, which is 360. We'll quickly solve that in the next new sheet. So we have 360 degrees minus theta, which is the fourth quadrant, of course. So here is 360 degrees. It's going to be minus theta. So it's going to be between 360 degrees and 270 degrees. So that makes it again the fourth quadrant where cos and secant are positive. All right. So now here we are with sine of 360 degrees minus theta. 360 is not going to change sine. So it's going to be sine itself. It's going to be sine theta, but it's going to be negative because sine is not positive in the fourth quadrant. Then we have cos of 360 degrees minus theta. It's going to be positive cos theta because cos is positive in the fourth quadrant and 360 degrees does not change anything. And tan of 360 degrees is going to be minus tan theta because tan is not positive in the fourth quadrant. And we have cosecant 360 degrees minus theta. Again, it's going to be minus of cosecant theta. Again, because cosecant is not positive in the fourth quadrant. And secant of 360 degrees minus theta is going to be secant theta because secant is positive in the fourth quadrant. And cot of 360 degrees minus theta is going to be minus cot theta because cot is not positive in the fourth quadrant, so it's going to be minus cot theta. And another quick clue that I'd like to give in the case of 360 degree minus theta is that now if you notice carefully, the minus theta that we first did falls under the fourth quadrant, right? Because I told you this is a positive theta and downside it is negative theta. So this 360 degree minus theta is also negative theta. 360 degrees minus theta and minus theta are coterminal angles because both of them share the terminal angles, the terminal sides. So this is also going to be the same as the negative theta. So that's a clue. You don't have to learn 360 degree minus theta separately. If you learn the negative theta, it applies to for 360 degree minus theta as well. Well, if you're wondering if 360 plus theta is going to be this theta, yes, it is. It is going to be the same as theta. So theta and 360 degrees plus theta are the same. So let me quickly write that down for you. So 360 degree plus theta is the same as the first quadrant here, right? So it's going to be the same. It's the simplest one here. So sine of 360 degrees plus theta is going to be sine theta. Everything is positive here. 360 doesn't change anything, remember? So cos of 360 plus theta is going to be cos theta. And tan of 360 degrees plus theta is going to be tan theta. And cosecant of 360 degrees plus theta is going to be cosecant theta. And secant of 360 degrees plus theta is going to be equal to secant theta. And cot of 360 degrees plus theta is going to be equal to cot theta. So it's the same as the first quadrant or the theta. So we can also say that 360 degrees plus theta and theta are coterminal angles. So it becomes a little simpler for you when it comes to 360 degrees. And so yeah, these are the trigonometric ratios of various kinds of angles. So if you know all these things, it's going to really help you to solve any trigonometric ratio of, of any angle of any magnitude. That's what is going to help you. So I'll see you. This concludes this video and this concept. I'll see you in the forthcoming videos with problems based on all these ratios that we did just now.